Okay, so I think we are live now. Let's get started. Yeah, okay, there's some problem with my screen sharing. Let me screen share again. Abhishek, can you see my screen?
Let me see. Yes, I can see your screen.
Okay, great. Okay, so let's get started for our next session. Good afternoon, everyone. Welcome back to AI Horizons, turning intelligence into impact, powered by AOlogic Technologies. I'm Jubin, and I'll be your moderator for today's session. Over the past few months, we have explored some powerful AI transformations from intelligent automations to voice agents, from computer visions to RAG-based systems. Every single one of those innovations had one thing in common, that is search. So, whether it's retrieving enterprise documents, analyzing customer history, or powering conversational AI, search sits at the heart of modern intelligence. But the landscape is evolving really fast. Traditional keyword searches have served businesses for decades, fast, reliable, rule-based. Yet, the rise of vector search is redefining how machines understand meaning, intent, and context. In today's session, it is all about answering a crucial business question: vector search versus keyword search. When you should use what? So, folks, over the next 35 minutes, we will be breaking down the following items. We will discuss about what keyword search and vector search really are, how they work behind the scenes, where each approach wins, where each fails, the real world use cases from enterprise applications, and practical framework to choose the right search strategy for your organization. Joining me today is Abhishek, our team lead in WebTech at Aeologic Technologies. He has been deeply involved in building AI-enabled searches, RAG pipelines, and scalable backend architectures for global clients, making him the perfect person to decode this topic. Abhishek, great to have you with us today.
Yeah, thank you, Jimmy. And hi everyone. I'm very excited here. So let's just start with the search. So search has quietly become one of the most critical component in modern application, as you know. So as most of the application you can see are using the search technology, uh, from e-commerce to knowledge base, knowledge management, from CRM to customer management. We rely on the search engine every day here. So now what changing is how we how the search works. So the technology we are now is evolving. So the keyword search, as we all familiar with the keyword search, it is greatly used in our applications. What exactly we are looking, if we know what exactly we are looking for, then the keyword search is greatly helpful.
Mhm.
And for the vector search, it shines when the user search based on the meaningful context. Let's suppose if you want to search something meaningful, then it will be greatly helpful with the vector search. So today we will go through the all the both approaches, how both works in the real world with the use cases.
Great, great. Thank you for that, Abhishek. You have already started giving me the differences between both. Let's get into the heat of the topic, right? So let's start from the basics. What makes these two approaches different, right? What is keyword search? What is vector search? What's the difference between them?
So yeah, the keyword search, as I said, it is based on the exact matching words. If you know what word or what context you are looking for, You can just
Hmm.
type that word, and based on that word or key phrase, it will show the some result. It so far what we are using it uh, nowadays, we are using in most of the applications. Uh, as you as you type the keyword, based on that keyword, the query is sent to the database, and from the database we fetch those query, and based on that query we simply display the result. So there is no such mechanism where we can uh, show the user. Let's suppose if a normal or common person try to communicate with our application, and he have some queries, and he may not familiar with the technicalities of that search. He may familiar with his issue, and he try to communicate with our application. So in that context, the vector search will be more relevant for him. So the major context what we have here is the keyword search is when we use the exact word matching. We have few technologies, we have some techniques around this keyword matching as well, like PFID and BM 25. These are some techniques uh, or search performance optimization. Based on this technique, we query some sort of data or more familiar data with that would be helpful for the user. So this will help only when the data is well structured. We have some query and role-based filter. We decide some keyword, and based on that keyword, we filter out the data from the database. So in this context, we will use, most of the case we will use the keyword search, and
Got it.
it will be natural and the fast way of getting the data as well.
Hmm.
So and, coming back to the vector search, it is based on the, as I said, it is based on the uh, uh, context. If you have some context data, and uh, you are trying to get the data with the semantic search, based on that
Hmm.
you can use the vector search. So how it works is we will figure out on the coming slide. We will take a look at how it works. But for now, we can say that we have to convert the embedding of the text, whatever the text format we have into a numerical representation, and store it into the vector database. So what vector database does is it tries to identify the similar context. So whatever the similarity between those two words, whatever you're trying to search, so it will try to figure out what are the similar context. So based on that similar context, it will try to get the data, and it will whatever the data we have from the vector search, we will provide it to the LLM or some other LLM, so that it have some context of our search result, and based on
Hmm.
our search result, it will uh, send us the data, the relevant data based on our query.
Right, right. Thank you for that explanation. So, in a nutshell, if we say in layman terms, right, so keyword search is basically on the textual part of the searches. Like there is a very long document, we search for the whole document with the keywords and then give the results. But vector search is when we add AI element to the search, we search the document, understand the context, and then give a more relevant answer, which is information rich, right?
Right, exactly. So keyword is
Awesome.
basically
Like,
what you type, what you have typed, you will get the
mhm.
result based on that. And vector
Right.
is basically what you meant to search. So whatever you want based on that meaningful context, they will show the result. Yeah.
Got it. Got it. Great. Thank you for that explanation. Let's move on to the next one, Abhishek. How does vector search, work under the hood? Because we have heard a lot of people hear about embeddings, but don't fully understand them, right? So how does this vector search actually work?
Okay. So yeah, there are three key features of three three method of three steps of working with the vector database or vector search.
Mhm.
So the first way is embedding. So whatever we have the text or whatever the data we have, we need to convert it into the uh, embed. We have to convert it in the embedding or vector format.
Mhm.
So we can use some open AI tool or one Gemini also provides some embedding tool. So we can use that embedding tool. So based on that, we will convert all our data into the embedding vectors. So what it
Mhm.
will does is it will convert all your textual data into a numerical vector format. So
Right.
the representation it would be like in the vector format if you're familiar with the vector. So the numerical representation of those text and it will be stored in the database. So once we store the data into the database, the vector
Mhm.
DB will index it properly. So we can use the vector indexing here, the second key point here.
Mhm.
So we have some familiar database resources here like Chroma, Pinecone, and these are some uh, vector database service provider. They can store your data and provide you the indexing facility. Based on
Mhm.
that, you can get the result. So the third step and the final step is similarity search. So whatever the user will search, based on that input, uh, we will try to or vector will try to figure out what are the closest vector set based on some technology they use internally, like coin similarity and dot product. And these are some technology they use internally to find the closest data set in the vector database. So these are the main technology how they use. These are the three steps basically to get the semantic data from the database. So it allows us you to query like if I can say the example how if let's suppose if I want to search for how do I want to reset my device. Okay,
Mhm.
so so in this context, you can see uh, I have some meaningful context, and the system will try to figure out what are the keywords we have put here, and based on that meaningful understanding, they will show me the relevant result. So this is how the vector search functionality works in these three steps.
Right, right. Thank you for that explanation, Abhishek. I think if you dumb it down, so basically it is first of all, we do the embedding generation, right? So embedding is basically converting our text data into numerical format that is easily be understandable and easily storable for the AI, right? So it will
Right.
convert it into its own binary form. Like we have binary for machine language, right? Zero and ones
Mm.
ASCII code is one such example. So for AI, they use embedding in which the data is converted into vector form, and then vector indexing is simply storing the data files or the embeddings in such a way that they are indexed. And from that, once we have a question or an input to search, first those vector indexing is taking out the relevant data and then giving out the meaningful information. For the example that you mentioned, right? If the user is asking, how do I reset my device? So if we are using keyword search, right? So, and if the specific keywords, how do I reset my device? If those keywords are not present in the document, then it will not give an answer, right? But if you are using vector search, it will understand the context, right? That the user is asking for the way to reset the device. So that context will help the AI to give us the contextual answer, which is more accurate with the help of vector search.
Yes, right. Exactly.
Great, great, great. Thank you. Let's move on to the next one. So, in what scenarios does, keyword search still win, right? There must be some scenarios where keyword search is over vector search, right?
Yeah, absolutely. So let's say keyword search will win when we have the precision of a critical uh, data. I mean, if I have the legal or financial document, and based on that financial document, you want the exact match of that data set. So there you on that context, you will provide a keyword, and based on that keyword, the exact financial document or legal terms should be presented in front of you. So in that context, you will use the keyword search. And second thing is, I can think uh, when the data is well structured in, let's suppose if we have a product detail, so it will be stored in the tabular format. It can be stored in the tabular format, and the SKU number, product catalogs, invoice number, these types of data should be is, used or searched based on the keyword. And let's suppose if you want to search the invoice number, based on that invoice number, you just want to get that invoice detail. So there's in this context, you will or you must use the keyword search. And the third thing I can think of is like you can if you have some filter operation, if you like to filter some key financial data or e-commerce data based on that keyword that you want. So in that context, you also need to use the keyword search. And in this way, I mean, whenever you are trying to use some keyword, and based on that keyword, you will get the result. So the latency will be very less. As you can see, the search is based on that keyword, and the computation is very low. And based on that computation, you will simply get the detail. So in this way, you will get the fast result, and very cost efficient, and the extremely efficient way. So in this context, you will also use the keyword search. For example, like I say, if you type the invoice number, if you type the license number or something like that, so based on that context, you will simply get the invoice detail or whatever the data you want from that invoice. You can get this detail. So in this context, you must use the uh, uh, keyword search instead of the vector search. There is no need of using or over engineering the vector search on this context.
Right, right, right. Thank you, thank you. Let's move on to the next question, Abhishek, right? So when should businesses switch to vector search, right? Let's talk about real use cases where, vector search outperforms keyword search.
Yeah, sure. So the vector search signs when the search involves around the natural language query. Uh, let's say if you want to get the company policy from the whatever the data source you have. From that company policy, someone tries to ask about some leave policy. So based on that context, he can search what is the leave policy on this company. Based on that context, we will get the natural language search. So in that context, you can use the vector search. And one more example I can say, let's suppose if you have the product-based company, and product-based company have lots of data based on or article based on the refund policies. Let's say if you have the refund policy and customer want to search based on the whatever the payment, how do we get the refund, and how to get the refund basically. So in this search, you can use the you have the some meaningful data. So in this context, you will use the uh, a vector search. And there could be some more example like if you have some emails or PDF or chats report, these type of data can be retrieved with the uh, meaningful words instead of just simple word like contact number or something like that. Instead of that, you can just type some meaningful sentences or paragraphs, paraphrase. Based on that paraphrase, the system or LLM will understand what the actual meaning of your search, and based on that search, it will show you the result. So building Uh, and one more thing I can say, if you are building a application like AI chatbot, we generally have this type of chatbot in most of the company that provides customer support system. So in that application or in that system, we can also integrate a modern AI system that requires the semantic relevancy of the uh, chat data. So in that also you can use the uh, RAG base or the AI chatbot. So in that system you can implement it uh, for the user. And there is one more thing. I mean, let's not completely rely on the AI search or vector search. We can
Mhm.
also adopt the hybrid model. I mean, some part in our application, it could be the vector search, or it could be the keyword search. Based on the scenario, we can decide wherever we need to have the keyword search and wherever we need to have the vector search.
Right, right. No, I think that is one of my questions in the list, right? We'll come to that. Before that, I think let's do a small demonstration of how we can build some search modules. I'm sure, Abhishek, you have a demo for us, right? I will give you some time to so that you can set it up. In the meanwhile, I can just let the viewers know, right? We have been in the IT field for more than 1.5 decade now, and we do a lot of AI activities, AI applications, and this is one of the fields where we can help. And in the upcoming demonstration, you will see how vector search and keyword search are going to work. So the screen is all yours, Abhishek, so that you can walk us through the demo.
Yeah, yeah. Thank you, Jimmy. Let me share my screen.
Yeah.
Let me know if my screen is visible.
Have you shared? I don't see it now.
Let me try again.
Yeah.
Okay. Let me know if my screen is visible to you.
Yeah, it's visible.
Okay, so as you can see, I have created a simple application, and on this application, you can see we have a upload option where we can upload our document, whatever the documents we have in our company, we can
Hmm.
upload it here. And based on that upload, let's say if I select some of the data uh, from my site, I have few files. I have already uploaded some files. I will navigate it
Hmm.
through. So these are few
Hmm.
files that I have used in this demo, and
Hmm.
I have already uploaded it. So once you upload, you have to wait for few minutes, about a minute, so that indexing will take place and it should be completed. So you have
Right.
to wait for a few minutes. Once that is ready, then the this chat box will be ready for you. So I have created a comparison here based on the keyword and the vector search. We can see the result in this chat box. So
Hmm.
I have already uploaded three documents here, and as soon I upload that document, the chunks will be created. I will show how it works. So let me show you a diagram so that you can understand the proper architecture of this demo. Before we going through that demo, you can see what we are trying to do is we have some documents here, right? So once we upload that documents, we will try to create some chunks based on that document file. We will not serve all the data in one go. Otherwise, the LLM mostly will hallucinate based on that data. If you provide a
Right.
large context of data to the LLM, it will hallucinate most of the case. So to prevent that scenario, what we will do is we will create some chunks of our files, of a large files. If you have thousands of or hundred thousands of lines of files, So you have to break some, let's suppose 100, 500 lines of code to a one chunks, and similarly we have multiple chunks. So what
Mm,
we have done is we have created multiple chunks here and provided those chunks into the embedding model. So
mm,
this is also a part of LLM or a small embedding model. We have a small embedding model. What it will does is it will get our textual data, text format data, and convert it into the vector numerical data set. So it will
mhm,
convert, it will do the heavy lifting of conversion of our text data to the vector data. So once that vector embedding is done, as you can see, we based on our chunks, it will create multiple embeddings. So all these embeddings will be stored into the our vector database store. Whatever the vector database store we are using, it will be stored in here. So
mhm.
once data set is stored and indexing will be performed as soon as we store the data. So after a few minutes, it will be ready for the query. So whenever our user takes a query, puts the input value, and a semantic search will be done on the vector database. So based on that data set or whatever the result from this data source, it will be provided into the Gemini or whatever the LLM you want to use here. So it will be
Right.
provided into the LLM model. So that model will take care of the meaningful data. So whatever you have typed, so based on this data set, it will try to figure out what do you actually mean and what you want to get it from here. So it
Right.
will convert that response, and the response will be converted and sent back to the user. So the major heavy lifting is done here. So LLM will not have entire your data set. Let's suppose if we have millions of documents and converted into the embedding data model or data source. So you
Mhm,
will not have all the data to the LLM. You will only put the data that uh, that is based on your search query. Let's suppose if I search for 200 megapixel camera, so in that context, whatever the data set coming from the data source will only provided to the LLM model based on that result. What I mean is, so only those data that have 200 megapixel that will be provided into the LLM model, not the
mm.
entire data set. So as you
Right.
can see, the computation and the resource will be very less used in this context.
Right.
So once the data set is ready and LLM will figure out what's the actual meaning of your search, and based on that search, it will provide you the result based on the whatever data set we have. So this is
Mm,
the actual working mechanism of the rack, or you can say whatever we have the system built in the demo here. So this is the actual context. And if you try to look into the deep, this is the actual mechanism when we will try to build the actual live production ready application. So in this
mhm,
context, you can see the upload, because for the demonstration purpose, I have created the upload option directly on this application. So in the
mm,
real life, we will not have upload mechanism because as you can see, we have multiple or very large files on our company. So we'll not provide all the data in from this upload mechanism, or
mm.
manually we will be doing this. It will take much longer time, and it is a manual task. So we will not doing this. It is just for the demo purpose I have created. But in the real life, real real application, what we will do is this process should be in background and it should be offline.
Right.
So let's suppose if we have a large document set, we will write a script. Based on that script, we will create multiple chunks on that script. Whatever the chunks are created, we will provide that chunks into the embedding model that we have already
Mm,
discussed. So whatever the chunks is created, the embedding model will convert that into the vector embedding data. and that will be stored in the vector database. So other than the functionality will be uh, time. Like this is the online process. Whenever the user uh, makes the query, that query will be triggered to fire and get the embedding models based on that query, and that embedding data will be get from the vector store, and that data will be provided into the LLM model. So
Right.
these will be feed into the LLM model, and uh, based on that LLM model, this will be returned back to the user. The response will be returned back to the user. So this is the actual working mechanism of our rack system.
Mm-hmm.
So coming back to the demo, so as you can see, we have a comparison mode. I have created a comparison mode based on the keyword and the vector search. You can search here. Whatever you
Mm-hmm.
type here, based on that, whatever the file I have uploaded, based on that, it will try to get the result. So I have
Right.
also tested few keywords and a few search tags, and for the demo purpose, I have created those here. So let's try with this one. Let's suppose if you want to get the scalability based practice, I am trying to search with this keyword.
Mm-hmm.
There is something wrong with this. 1 minute. Let me try again.
Yeah, yeah, sure.
Okay, yeah, we have the result now. So as you can see, it took some time because, as you know, we get the data from the vector database store, and based on that result, we provided that result set into the LLM model, and that LLM model process those data with the meaningful data, uh, and
Right.
and that data is provided to us. So that took some time. I mean, if you want a very quick solution uh, based on your keyword, so
Mm-hmm.
then you can use a keyword mechanism. But in this case, you can see we have some meaningful data based on our search parameter. So as you
Mm-hmm.
can see, we have I have created two sections. The first section is for the uh, keyword search, and the second is for the vector search. So as you can see, whatever the relevancy of this result, I have provided with the percentage value. Based on these
Right.
percentages, you can see we have the winner of vector search here.
Mm.
So if and we can see the conclusion here, whatever the vector search and how it is calculated based on the natural language question. This is
Mm.
declared that vector search is winning here. And if I take a look at example with that second example, in this
Mm-hmm.
case, you will see the keyword search will win because you can see we have exact matching of some data, and based on this data set, we have the keyword winning here.
Right.
So yeah, this is the actual demo. This is just for the demo purpose. But yeah, in the real life example, we will follow. We have to follow this mechanism, and based on this context, we will have the rack system properly working based on the vector search. Yeah,
Got
over.
it. Got it. Thank you for that demonstration, Abhishek. I think it was a great one. I think this is one of the few demos that we have already implemented for other clients. And if anyone wants to have any, search-based AI application or any requirement, they can definitely reach out to Aeologic Technologies, and we'll be able to help you out. So moving on towards our questions, Abhishek. So how can businesses decide which search strategy to use when, right? Can you give some decision framework?
Uh, yeah, I mean, if the business need exact matching, I mean, based on the ID, some sort of ID, or based on the SKU number or the log semantic meaning. So in that context, the business should use the uh, keyword search based on the exact matching. So if
Mhm.
the business required such scenario, then they should use the keyword search. And if anywhere we want to use the semantic meaning or contextual query, for that query we will use the vector approach. And even I would recommend we should have the hybrid system where we can
Mhm.
have both mechanism implemented together with the precise data and the meaningful context. So the best approach I would recommend is going with the hybrid model.
Got it. Got it. Okay, I think with this, we conclude our today's session. I think it was a great one. Thank you, Abhishek. Let me give you a quick brief to the audience so that we are at a place where the audience is also understanding. And let me conclude it. Thank you, Abhishek, for such clear and practical breakdown of vector versus keyword search. To everyone who joined us today, here's the takeaway, right? So keyword searches find exact words, and vector search finds meaning, and hybrid search brings the best of the both worlds, right? So in a world where enterprises manage millions of documents, conversations, and knowledge sources, choosing the right search strategy can dramatically improve discovery, decision making, and productivity. At Aeologic Technologies, we help bringing organizations build modern search stacks from RAG pipelines to vector database to hybrid systems, ensuring faster, smarter, and context-aware information retrieval. Your AI systems are not only as good as when they can retrieve, and sessions like this help us navigate those choices. So, thank you again for joining us today. Make sure you follow Aeologic Technologies for on LinkedIn and YouTube for upcoming demos of webinars and hands-on sessions. With this, I'm Jubin signing off. You all have a great weekend ahead. Thank you.
Thank you, everyone.